Hi, in this video we're going to install a web server. So on server B here we're going to install the service called IIS, which is the Microsoft initials for web server. So what we need to do is pull up server B and pull up our server manager and add roles and features, and next, and what we're looking for is web server IIS. Now you'll notice that it's already got some of it installed. When we installed some of our previous services, probably routing and remote access, it would have installed some of this web stuff as well. So we're just going to expand this out, and we can see that we've got, we're going to expand out the web server, and it looks like we've got a fair majority of this already. Common HTTP features, redirection, web dev, publishing. So this is a request monitor. Okay, performance, dynamic content compression, and base authentication, centralized SSL certificate, digest authentication, client certificate mapping authentication, and URL authorization and Windows authentication. And then in the application development we've got all of this .NET and ASP type stuff. Okay, what we need to do is test the existing functionality and see if we need any more of this stuff in place. So I'm going to minimize this, open up Internet Explorer. It goes out. What we want to do is open up another tab and type in localhost. And it actually brings up the web server's homepage. What we're going to do is have a look at opening up the file explorer. If we go to drive C, we'll see this thing called inetpub, and if we click in there we can see a thing called www.root, and that is the homepage of the web server. So if we have a look at IIS start and open it with, say, a notepad, we'll see some HTML type document, and drag down a little bit. The image source is this thing here. Whoops, gone too far. So it's IIS-85.png, which if we have a look at it is actually this little PNG image here. So what it does is it displays that PNG image. So if we just double click on that, we'll see that that's actually, this is in Paint, we'll see that that's the front image that we see on our home page. Now we could change this, you know, we could add some text to it. Text, I don't know. You know, Marty. Make it bigger though. And bold. And that move that around a little bit. Okay, so I've just stuck my name on there, and I'm going to save that file, save as, and 85 call that revision B, 85 revision B .png. Okay, so I've just changed it. We've got a new one there. So on our thing here, if I put revision B, it'll pull up the modified version of the home page. And what we'll do is we'll just drag along here, have a little bit of a look. The title part here, I might change that to Marty's IIS Windows Server, you know, to suit my new image, and go File Save. And on our you know, if I reload that, whoops, what's happened there? Let's go localhost. And I want to reload it, and you can see now that it's Marty's IIS, and it's got the new PNG Marty version of it. So you can see that that is actually our web server's home page. And close all the tabs, don't need that anymore. And it's all in this this folder here, www root in inet pub on drive C. So that's our web server. What we need to do is see whether other people can get to this machine, and I'm going to go to the Windows 10 machine and do a search for iExplore, Internet Explorer, and I'm going to send that to open the file location, and I'm going to send that to the desktop. Yeah, desktop's a good place for it, and I might also drag it to the launch bar as well, taskbar. So if I've got this thing open, okay, let's go www.google. Okay, so the account that I'm logged in as, which is the administrator's account, on this computer does not have proxy details set up. So we need to look at the internet options, connectivity, LAN options, and we need to put our proxy server in. Now that's only required because we're here at TAFE. If we were at home or in Get Well Medical itself, then we probably wouldn't need a proxy server. So so we just put the standard proxy in, and I'm just going to go back to the home page and put Google in there as well, and apply and go OK. So let's hit the home button, and we're out to Google, which is what we'd expect. I don't want it, and we can go to images and go you know, Fox, and we're going to get pictures of foxes. That's fine. The other thing we probably should have done is avoid the proxy server for local addresses. So I need to bypass for local addresses. So anything that starts with a, for example, a 192.star, I don't want it to go to the proxy server. I want it to go straight to the web page. Because what we want to do is we want to open up another tab here and what we want to do is go to server B. So if I type in server B, well, it's gone out to the internet. So if I go https:// and go server B, let's just see where we get to this time. Can't be displayed. Okay, so let's just go / server B to see whether we can actually get to that machine. I think that probably was. If we go server A, we should find the shares that are on server A, which we do. So I'm thinking that it's when we go to server B as well. You've got to have the double / in the front. We're actually going to server B, so I think we're getting there. But web-wise we're not. So let's just put in the IP address 192.168.10.3. And let's do it without the, okay, so it was HTTP, not HTTPS. So it is getting there. Let's just see if it gets there also with putting the name in server B. I'm thinking that it did, so let's just test it again to make sure. Let's Google separate tab HTTPS server B. Doesn't like it under S, but with HTTP it certainly does. It gets to Marty's website and Marty's services. So that's under the name server B. So it is working. Our server is installed and working, and fortunately we didn't have to actually install it ourselves. Normally on server B, under here we would have just gone to the web server here, tick the box and gone next, install, and it would install all the things that we need. Now in our case that had already happened, and I'm assuming that it's probably already happened on server A as well because of the additional services that we've installed there. So we're going to quickly just check that. And this is a slight issue with servers, that whenever you install just about any service, it also installs a web server, which can be you know, a vulnerability, let me say. So if I go to drive C, there's an iNet pub, there's a www root. Yes, it's got a home page, so if I was opening up on here and going out to the internet and then went go to on another page localhost, it goes to its own web server. So you know, a lot of the servers just automatically install a web server, which is a vulnerability. Web servers not being particularly secure unless you lock them down properly. So Microsoft tends to install a web server because they use web-based configuration for lots and lots of their different services. So you'd start installing services, you're going to get a web server as well. It's just one of the components of whatever service you've installed. Okay, so we do have a web server on server B, and we can access it from our Windows 10. And the other thing that I'd like to do on server A is kill all the tabs, is to go to the administrative tools and open up DNS and expand out our forward lookup zone and our domain name. And what I want to do here is to install what's called an alias record. So here we just do a right mouse click in here and new alias. They call it a CNAME. And what we're going to do is give a nickname to server B, and I'm going to call it Web because it's our web server. So I'm just going to call it Web, and then I'm going to go and point to it. So browse server A forward lookup zone in our domain. Let's find server B. Now there's server B. And now its nickname is going to be called web.gwmp.com. So if I just type in web, it's going to go to the web server, which is server B. Okay, so we've just put in an alias or a nickname for our web server. Okay, so back onto our Windows 10 machine again. On here, you notice we went HTTP server B. If I open up another tab and go http:// and go web, I also get to the same server because it's using this alias or this nickname, which is looked up in DNS and resolves back to server B, and hence we get the page. So we can prove that a little bit just by opening up a command prompt and going ping web, and it resolves back to 10.3. Now it's not pinging, probably because I've got a firewall turned on. So if I ping server B, it's the same thing. 10.3, and of course it's not pinging because there's a firewall turned on. If I turned off the firewall, it would work. Okay, so this video was all about installing the web server, and we found that the web server was turned on automatically when we installed some of the other services. That does happen. We checked the functionality of our web server, and we found that we could also install a DNS record called an alias record, and here it is, that's the alias record, and create a nickname for a machine. Now this is quite useful if we've forgotten to actually name the computer, and it has that awkward Windows name. We might have even promoted to being a domain controller, and we can't change the name of the machine, but we can give it a nickname which is nice and useful and easy to use. So that's what I would suggest, is that we just use the nickname, which is often much easier than the full machine name. And we've proved that our Windows 10 machine, not in the same subnet, is actually getting it from the web server. An interesting thing that we could do also is to do a trace route. Trace RT -D. -D tells it to stop doing DNS lookups, so it just goes via the IP address. And I'm going to go web to see whether it actually gets, yes, it's resolved, and it should get to, we've got a request timeout. So it looks like the firewall's actually on this computer. That's interesting, isn't it? We're not getting could be that the firewall is on both this computer and the endpoint, which is the web server. So let's just halt that for a moment and we'll give that another go. So if we have a look on our panel here and there's a Windows firewall, yes, we have a firewall on. So let's just turn the firewall off temporarily. Normally what you would do is you'd just allow pings, but leave the firewall on for the rest of it. Okay, so that's the preferred way of doing things. If I go to our server B, I'll do the same thing. Have a look at the firewall. Yes, we've got a domain firewall on. Okay, and on our server A, we'll just do that. It'll be the same as well. Domain firewall. Yep. Okay. So back to our Windows 10 machine. So if we give that another go, it's gone basically straight there and got a response. Which is interesting. From our server B, if we do a trace route, so let's open up a command prompt, cmd, and let's make the font a bit bigger. Okay, so in here we're going to ping Win10, which is the name of our Windows 10 machine. So it knows that it's 10.100. Okay, that's because it's currently in the same subnet. Okay, that's why our trace route went straight there. What we should do probably is to put our Windows 10 machine a little bit further away. So let's go devices, go down to our network and move it to switch 2. So what we'll do is our network there is trying to get another IP address. So if we do a IP config /all, we'll see now that we've got one in the 20 subnet, 20.100, and we'll do a ping web, so we can see that it's pinging the web server. It gets found via DNS to what it actually is, server B, and what its IP address, and then pings it. And if we trace route it, -d web, we can see that it goes through the router at 20.1 and then goes to the web server. So if we try and do that in reverse, what we want to see is that the web server does not bounce it off the front ADSL, but actually goes straight to the router and then straight to our Windows 10 machine. So if we do the same thing, so we go trace routes -d, and we'll go Win10. Okay, now that's interesting. What it's going is tracing the route to 10.100. It's still thinking that it's in the same subnet, which it probably was until we just moved it. So let's give it another go. search CMD. Okay, ping win 10. No, it's still thinking that it's at 10.100. Okay, so let's ping it directly. Ping 192.168.20.100. So it knows that that's it. If I try win 10 again, no, it still thinks it's 10.100. We probably should flush the DNS and tell this thing to go find the DNS record for win 10 again. So the way you do that is you'd go ipconfig / flush DNS. That flushes the DNS resolver cache, and then we'll ping win 10 again. And now you can see that it's picked up that it's 20.100 rather than 10.100, and actually pinged it. We want to trace route it. Trace route -d win 10. And we can see here that it goes directly to 10.254 and then to 20.100, which is where the Windows 10 machine actually is in the second network. And it does not bounce it off the front ADSL. So it looks like all our routes are working. Our machines are finding the web server. We've used a DNS alias in order to change what name that we need to go to. We can create a shortcut or a nickname, and it doesn't matter whether our Windows 10 machine is in the local subnet or in a different subnet. We'll just prove that again just by going to another tab and going web. I'll just type in web, should go there, and it does. Okay, so you know, it doesn't matter which subnet we're in. All our reverse routes and all that sort of stuff is working, and our Windows 10 machine can get to the web server that's installed on server B. And we know that the traffic is not being bounced off our ADSL at the front. Okay.